Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at configuring IP default static routes. We'll be discussing default static routes, configuring a default static routes, and then verifying that default static route. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Default static route is a static route that matches all packets. It matches any packet on our network. It's a single route that represents any network that's not in my routing table. What happens is when a router gets in a piece of information, looks at the destination IP address, and it looks at its routing tables. Does it match here? Does it match here? Does it match here? If it doesn't match anything, then it looks for that default static route. And if it's set up, it will send any packet that's not in my routing table to that default static route where we have that set up. Typically, a default static route is also known as a gateway of last resort. You can use these two terms interchangeably. Default static route, or some people say a default route, or gateway of last resort. You can use those terms interchangeably. Routers commonly use default routes when they're on a stub network. And what a stub network is, down here you can see that this yellow box represents a stub network. You have a local area network. It has some PCs on it, switches, just one network, and that router only connects to one other router. And so it's sort of on its stub on the end. That's where we have this idea of a stub network. Or when you connect up to an ISP. When you connect up to your ISP, a lot of times you have default routes. Because you have a default route pointing to your ISP. Think about your local area network. On your local area network, you keep track of all the devices, all the routing on your network. But on the internet, there's lots of routes. There's thousands and millions of networks out there. You don't want to keep track of all that because it takes RAM, takes processor, takes specialized expensive equipment. You don't necessarily want to keep track of all of that. So what you do is just keep track of what you control. Those networks, those local area networks you can control. And then if it's not one of your networks, we send it off to this default static route. This default static route points it to your ISP. Your ISP is set up to get it to its final destination. It keeps track of all those networks on the internet, how to get to them. And you don't have to keep that all in your RAM, and you don't have to process all of that information. When we set up a default static route, we do a couple things specials in that IP route statement. For IP version 4, where we have the network address and the subnet mask, we actually enter in all zeros. So we enter in 0.0.0 for the network address, and for the subnet mask, we enter in 0.0.0. Now, these are typically referred to as quad zeros. The saying 0.0.0 is fairly repetitive, and a lot of people just say quad zero, and they understand, well, there's 4 zeros, 0.0.0. If you have a network address of 0.0.0 with a subnet mask of 0.0.0.0 or quad zero in the route, it will match any network address. Basically, you're saying, I don't care where you're going. I'm just going to send all traffic this way. The command to set this up for IP version 4 here, once again, we're dealing with the IP protocol. We're dealing with routing. Then we enter in our first quad 0 for the network address, our second quad 0 for the subnet mask, saying, I don't care what your destination is. I'm just going to send it out And then it's either the next hop IP address or the exit interface. I don't care what network you're going to, I'm going to send you this way. Hopefully that device will then be able to get you to its destination, or at least one step closer. If that device doesn't know how to do it, I'm willing to bet that device has a default static route set up that'll point it to another device. And so it'll get to router to router to router until you finally get to a router that knows how to deliver that information to the correct network. For IP version 6, that default static route is similar, except you use the IP version 6 prefix and prefix length. You put in : /0, and that'll match everything. That makes this the configuration statement here: IPv6 route : so that is all zeros in this portion, and then our prefix length of 0, our network portion, our host portion. And then you can either choose the next hop IP address or the exit interface. It processes the routing table. If there's not a match, it gets to this default static route at the end and says, I'm just going to take all this traffic and push it on to this either next hop IP address, or just push it out the interface, and the device connected to it, it'll be able to handle it. I hope you're liking this episode on configuring IP default static routes. If you have the time, please leave a comment and let me know what you think about these IP default static routes. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. To configure a default static route, what we're going to do is we're going to start on R1. We're going to configure it on R1. If we think about this, you're in your company. You run this stub network here. You keep track of all the networks, all the routes on your network, and you don't want to keep track of what's all on the internet. And so this network here, you can think of this as your ISP. They're the ones that keep track of all the millions of networks out there on the internet and how to get to them. You don't want to clutter up your router with all that information. And what we do here is we have routing set up for these two networks, the two directly connected networks. So 172.16.2, that's a directly connected network. We know how to get there. 172.16.3.0 network, that's another directly connected, so we know how to get to there. But if it's not one of these two networks, we're going to set up a default route that points it to R2. And once again, we can either use exit interface or the next hop IP address. If it's not 172.16.3.0 or 172.16.2.0, it's not in my routing table. I'm going to go through all the entries in my routing table. I'm not going to find that. And then it's going to hit that default static route and say, any traffic that gets here, I'm just going to send it to either the next hop IP address or the exit interface. How we'd go ahead and configure that would be right here on R1 with the IP suite we're in. We're looking at routing. We enter in our quad zeros for the network address and the subnet mask, basically saying any traffic here, we're going to send it to the next hop IP address. Next hop IP address is 172.16.2, and then this is .2 up here. We're going to send it to that next hop IP address. Process all the entries in our routing table. If it's not there, the router looks for that IP route that has the quad zeros in it and then sends it to the next hop IP address or exit interface. Our example, we're using next hop IP address. IPv6 does the same thing. IPv6 route, we put in the : /0 represents we're going to take any traffic. Prefix, we don't care what it is. We're going to match everything. And then we're going to send it on to, this is the next hop IP address. This next hop IP address would be right up here. It has to be on a network connected to R1, but not an IP address on R1. It has to be the far side. So that would be up here. That's how you go ahead and set that up. The operating system identifies it here as the zeros. as the static default route. If it sees all the zeros in there, it says, hey, this is our default static route. To verify our default static route, we can go ahead and do a show IP route. We did a little bit more specific show command. Instead of show IP route, we did show IP route static, and it just lists out the static information. It's going to say we have a static route, S. We can look up here in the codes. That's what the S stands for, is static. We have the network address of all zeros, subnet mask of 0. So we're going to match any traffic and send it to our next hop IP address. We're going to send it right there to our next hop IP address. The other thing to look at right here is this asterisk. This asterisk is down here. It's an S and then an asterisk. What this says is this is a candidate for the default route. This is a candidate. We have an administrative distance of 1 right here. Remember, our administrative distance for static routes is 1. So this is a candidate. If a static route has something lower, which it could only be a directly connected network, that would be that, and that's why it's a candidate. If you'd set the administrative distance to something higher, something could be lower than that, and we'll talk about that here in a little bit. Verify on a IP version 6 network. Once again, we do a show IPv6 route static here. The entry down here, we got a code for an S. We see that we have the ::/0 representing our prefixes all zeros. Our subnet mask is zeros. We're matching any traffic that gets here, and this is the next hop IP address on your ISP router that you're going to send it to. It was my pleasure to provide you with this wonderful episode on configuring IP default static routes. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.